Welcome everyone to Strait Science. Strait Science is an evening seminar series put on by UAF Northwest Campus. We're here tonight, and also UAF Alaska Sea Grant in Nome. Both UAF Alaska Sea Grant and UAF Northwest Campus, we are public servants of the Bering Strait region. We serve all peoples of the Bering Strait region, which is the homeland and waters of the Inupiaq, Yupik, and St. Lawrence Island Yupik peoples. And tonight, we've got a number of people online and a number of people in the room here. So we're trying to come back to life after the pandemic and get a little bit of everybody we can online and in person. So welcome, you guys. Tonight's speaker needs really no introduction. You can say Rick Thoman, and everyone's like, oh, is there weather or what's going on? And that is true. Rick is he's the climate specialist. Though he did live here in Nome in the 70s, he is the Alaska climate specialist for the Alaska Center for Climate Assessment and Policy at UAF. Gosh, we hear Rick on the radio. He's in the Nome Nugget every week. He is looking out for us. You can join him on Facebook, which I think you'll plug your site. And really, it's a treat to have Rick in town. And we also have a little National Weather Service in the house right now tonight. So also be thinking of your maybe questions about what's rolling in starting this weekend. That might be of interest as well. With that, the man who needs no real introduction in Nome, Rick Thoman. So take it away, Rick.
All right, thanks, Gay. And thanks for having me. I cannot tell you how happy I am to be back in Nome. It's first long COVID drought, and I'm just thrilled to be here in person. So, Strait Science tonight. What I'd like to cover, certainly the winter of discontent here in Western Alaska, and really indeed in much of the state. Have a review of what's happened, take a little bit deeper dive into sea ice around the region this past winter, and then finish up with the outlook for spring and early summer. And undoubtedly, the interest will be a little closer in time, as in starting tomorrow night or Saturday morning. And Ryan Metzger with the National Weather Service, Fairbanks, is in the room and will answer all possible questions about the short term. All right, see if we can make the technology work. All right, before I dive too deep in, I do want to acknowledge, okay, we're sitting here in Nome, and weather in Nome matters, but what's happening in communities all around Western Alaska matters a lot too. Nome has the advantage of hub community. It's got a long climate record, but that shouldn't make us lose sight of the fact that we got a whole slug of communities in very different environments in this region. That's one of the things I love about Western Alaska, is the environment is so varied over very short distances. And I just want to acknowledge the peoples and the communities of the Bering Strait region. All right, so this is my, if you've been with us before in the spring Strait Science, I like to do these timelines. This is probably the fourth year in a row I've ginned these up. I find these very useful as they accumulate over time to look back. And so this is just some of the highlights that I picked out for Nome and Western Alaska here. A lot of things to fuel our discontent that the communities picture there, and then starting off early November snow. So by modern climate, not too different from normal for the first significant snow in early November, but then most of it melted out with the warmer weather and rain later in the month. And then the calamitous rain and snow in early December, enough rain in some communities to obliterate the thin snowpack that had formed. Of course, here, terrible freezing rain, driving the muskox off of the hills with tragic effect. Finally got some sea ice in mid-December, but then we had those strong north winds right around solstice, and we'll have some pictures, but something I certainly thought I would never say, a winter solstice in Nome, and just ice-free seas from the beach. And that was followed on, if you might remember, Christmas morning with the strong north winds continuing, and we had the lowest observed ocean level on the Nome tide gauge, almost 6 feet below the mean lower water. And was the lowest observed sea level since that gauge was installed in the late 80s. Pretty quiet January, finally, a little bit of release. Not that there wasn't any weather, but compared to what we had earlier in the fall, wasn't particularly cold, although we did have our coldest week there in mid-January, at a 7-day average temperature of 12 below. That's kind of typical for Nome, no great shakes, right? But then the storminess returned in February, and then in early March, greatest March precipitation event on record in Nome, possibly until this weekend. I think that one was going to hold actually, but this is going to be plenty big, and another stormy March in Nome, and we'll talk more about that. All right, I like to show this. So this is just the average temperature departure from normal for Nome and Unalakleet on top, and Nome on the bottom since November 1st. Of course, the red bars are days that were the average temperature was above normal. The blue bars are days that were cooler than normal. Now, just looking at that, both Nome and Unalakleet had more days warmer than normal than cooler than normal, but Nome was much closer to normal, just 1.2 degrees since that time above normal, and it is almost a 50-50 split. Now, definitely Eastern Norton Sound had more warm weather, and you can see at Unalakleet almost 2.5 degrees above normal for that whole stretch there. We don't have, unfortunately, with the FAA weather stations in the Bering Strait. I'd like to show something on St. Lawrence Island here, but none of the weather stations have sufficient data to do that. I think that it would look probably, it would look a little different than this because, of course, normals on St. Lawrence Island nowadays are always above normal until the sea ice arrives, always above normal in the fall, till the sea ice arrives. And this year the sea ice didn't arrive until right around Christmas time. And so there would be a lot of red on the early part, but then cool, some below normals since then. Here's how it played out at Nome at the monthly level, so the climate level. Precipitation, there's no months since November that have had below normal precipitation in Nome. Obviously, March is not complete. That bar is going to be much bigger by the time we get to the end of the month, and we're going to wind up with 3 or 4 times the normal precipitation for March. Probably won't make the record level of 2018, but never say never, right? Average temperatures are on the bottom. The bars indicate the above or below normal, and then the numbers are the observed average temperature. So early winter, warmer than normal, cooler for February. Again, March is not final. My guess is it's going to wind up pretty close to normal, or maybe even a little above by the time we get to the end of the month, but it's going to be close to 0. So warm early, normal to cooler late. March precipitation should be 3.75.
Okay. That's a question.
So this is through 2 days ago. Normal precipitation through what's that? 21st is a little over ½ an inch, and we've already had 1 3/4 inches. So one of the most common things that I get asked, oh, it's La Nina this year. What does this mean for our weather? Surely this must be the only possible thing in controlling our weather, right? No. So what I've done here So as some of you may know, this was our third consecutive winter with La Nina conditions. La Nina conditions just are simply describe the temperature departures from normal in an area near the equator, south and southeast of Hawaii. And why do we care if the water temperatures are a ½ degree below normal in that area, 5,000 miles away? The answer is because it controls where those big tropical thunderstorms form, which in turn affect the jet stream. And that's how ½ degree cooler than normal water way south of Hawaii can affect our weather here in Alaska. So what I've done here for the second or third years of back-to-back La Ninas, I've just plotted the departures. This is since 1950. You can see in the 1950s through the mid-1970s, when we were in a second or third year La Nina, winters were consistently cooler than the long-term normal. Since then, much more of a mixed bag. What I get out of this is, at least in the modern era, if you tell me, I know it's going to be a La Nina this year, and it was last year too, what does that tell us about the upcoming winter in Nome, at least temperature-wise? Nothing. Could be warm, could be cool, right? So classic, classic climate forecast. But one of the things that many La Ninas do, and is hidden in this 3-month, reducing 91 days down to one number, is there's a lot of variability in there. So most recently 2011-12, which had warm December and warm February, but it was sandwiched in incredibly cold January. It's one of the coldest months in the modern era in Nome. But so on the whole, it wound up a bit below normal, but not dramatically. Similarly, in 1999, 2000, very cold December, more moderate in December, and then way above normal in February. So on average, wasn't far from normal, but no one, if you lived through that, you would not have said, oh, that's a normal winter. No, it was really cold, and then it got very mild. So that is a feature of La Nina winters, that variability. And we'll see some of that here coming up. This is another graphic I like to do. So just to explain this, the blue bars are the amount of precipitation that fell on each day. The black dash line is just the cumulative total. And the green line is the normal accumulated precipitation. All of this starts in November and goes to the 21st there. Now, what I like to do here is highlight some of the notable events. And this winter, being the winter of our discontent, I had to use the word rain quite a bit in this graphic. Of course, a little bit of rain, especially early in the winter, is not anything new for Southern Seward Peninsula, but except for January, every month has got an annotation of rain there, and that is pretty disconcerting. Here's an example of some of that rain. That's from early December there, out in Dexter. And if you were here, this is not going to be an event, storm event that you're likely to forget. That's like New England like freezing rain. I mean, that's, what's that, an inch of ice there on those willows? Really, really dramatic, with big impacts all the way around, not just, of course, in Nome, but all across the region. This was the same weather pattern, same series of storms that not only produced all the rain here, produced rain all the way onto the North Slope, and Utqiagvik on December 5th got up to 40 degrees, which is the highest temperature ever recorded there in the last century, anytime between late October and late April. So really a historic level event. Now, this winter has actually not been terribly windy when we look at the full time since November, except there's a lot of days with low wind speeds, especially there January and early February, but we've had a slug of very windy days. Here's the average wind speed of 25 miles an hour on the vertical axis there. And you'll count that there's 1, 2, 3, 4, 5, 6 days meet that criteria. Saturday might add another one. And how unusual is it to have that many windy days? Nome's a windy place. That doesn't sound that unusual. Actually, it's very unusual. Here's a count since the late 80s of the number of those very windy days each November through March. And you can see the last 3 years really stand out like a sore thumb compared to the previous 35, almost 40 years now. So most of this record since the late 90s is all from the automated observation at the airport. So I think that's an apples to apples comparison. But clearly the recent years have really been quite extraordinarily stormy in terms of average wind speed for Nome, or at least the number of windy days. All right, now we're gonna continue to get our broad paintbrush out. So November through February, this is the average temperatures relative to our current climate baseline. By international standard, we're using 1991 to 2020. The colors here are in categories. So in climate forecasting, even climate analysis, we often do these in rather than specific degrees because climates vary greatly. We often do these in categories. So near normal, significantly above, and significantly below normal. And so these graphics from our colleagues at the World Climate Service bin the average temperatures for this 4 months into significantly above normal, near normal, or significantly below. And you can see that with a nice little hole there right over the interior Seward Peninsula. Otherwise, Norton Sound northward, most of the interior South Central fell into that significantly above normal category for the 4 months as a whole. A little bit different in Southwest Alaska where they fell into that near normal category. Notice down along the Aleutians, basically the Pribilofs on south, also significantly warmer than normal for the 4 months as a whole. Reduce 120 days to one number, or in this case, one category. Here's same graphic with precipitation, again, relative to 1991 to 2020. Now we've got some differences here across the Seward Peninsula, basically from about Gullivan northward and westward, above normal precipitation for the 4 months. Eastern Norton Sound, St. Lawrence Island through February fell into the near normal category. This darkest green area here, down here, Pribilof Islands, and farther west across the southern Bering Sea, that darkest green meant that this November through February was wetter, had more precipitation than any November through February in our 30-year baseline period. Notice that not much of the state here wound up below normal precipitation. If you were lucky enough to be in the heavy snow in Anchorage in early December, it was really heavy, but it was really, really small scale. On this map, you know, one pen width from the northern Kenai Peninsula to the lower, you know, basically Wasilla is the area that had that really heavy snow. So it doesn't show up in this kind of larger scale analysis. So speaking of snow, now, of course, for much of Alaska, mainland Alaska, most of the precipitation that falls November through February is snow. So this is going to look a lot like the precipitation, but for about the Seward Peninsula on southward in Western Alaska, where there is a significant, or there can be significant rain, especially in November, the pattern looks a little different. And now notice snowfall a little bit below normal from about the Bethel area up towards St. Lawrence Island. For Nome area, though, through February, still in that significantly above normal snowfall. And we haven't added in the March snow yet. This will look different in 2 weeks. So speaking of which, here is the snowpack analysis as of last week. So now here, what we're looking at, this is from the same weather model, or same same climate analysis model that I was showing you just there with, but this is not from the World Climate Service. This is my graphic. And so I've included much more detail here. This is the snowpack relative to normal. Snowpack here, we're referring to the amount of liquid water in the snow. And you can see, so this is now includes the early March storms for Western Alaska. YK Delta, way below normal snowpack. You can see that on webcam, the FAA webcams. There's grass showing through, tundra showing through in some communities there. Here, though, with all the snow, been a big increase in snowpack water relative to normal over the last month. And the Nome area there, about 150%, so 1.5 times the normal snowpack in this analysis. St. Lawrence Island is also catching up. The heaviest snow relative to normal has been up along the Chukchi coast northwest of Kotzebue. And finally, winds, always a interest for the Nome area. If you were with us last year on our spring program, this purple area showing where it was significantly windier than normal, that covered almost all of Western Alaska, including Nome. Not this year, as we saw in the airport daily data. We've had some windy, very windy days, but also some days with relatively low winds. And even in this categorical analysis, average winds for the 4 months below normal over eastern Norton Sound. Southern Bering Sea that had all that precipitation, actually a large area there from north of St. Paul Island westward, was in the top 2 windiest Novembers through Februarys. All right, so turning to the oceans. Average ocean temperature departure from average here for now here we're looking at, this is actually the 3-month, December through February. And you'll notice basically the below normal areas there in the northern Bering Sea. That's partly an artifact of just where the ice was, the way that ocean temperatures are handled in ice covered waters. The important thing to point out here, to my mind, is south of where the ice has been this winter, the entire Bering Sea averaged significantly warmer than normal. Outer Bristol Bay there, especially warm. Again, this is a 3-month average. Last winter, we had persistently above average temperatures in the Western Bering Sea, but south of the ice edge near Alaska, even where there was no ice and the ice never got there, Bering Sea temperatures were below normal last winter. Very different pattern this year. And this is in part, I mean, there's a chicken and egg issue there, but this is in part why, as we'll see, the ice has not managed to get very far south this winter. So turning to sea ice. Yes, this is a thing that I never expected to see. This is a stunning photograph here, December 21st, beautiful sunrise, and there is no ice to be seen. I would never, ever, ever thought that that could happen. Here's a graphic that I produced, and this is a spaghetti plot. Looks like a plate of spaghetti's been strung out there on my graphic. But what this plots is the daily sea ice extent. Doesn't say anything about thickness, doesn't say anything about quality, just where the ice is. This is every winter since 1978, 79. And then I've highlighted in blue is this year, in green is last year, and the thick black line is just the 30-year average. Now, a couple of interesting things here I want to point out. Very low ice extent in early December. No surprise with all those south winds, all that storminess. At one point, it was actually a record low for this 45-year period of record. Then a very steady increase mid-December through mid-January. And look what's happened since then. Up and down, up and down. And that's reflecting the variable, the changeable weather pattern that we've had across the Bering Sea. Periods of north winds, and then we shift to a week or 10 days of south winds, the ice retreats north. Then the north winds come back, the ice goes south. This is definitely not a pattern that we see every year, but we've executed now, what, 1, 2, 3, this is basically going to be the fourth little peak. The ice is starting to come down now and will come down more with the another impending south wind event here. So really, that's a nice reflection of just how variable the weather pattern has been. Even in January, which wasn't particularly stormy for, at least for the Seward Peninsula, even showed a little bit of that as well. You can see overall, the sea ice extent almost entirely below that thick black line, did spike above it a little bit there in mid-February, but and with the south winds coming now, we've surely reached the maximum ice extent for the season. From the National Weather Service sea ice program here, here's how the concentration maps look through the season. The lead analyst is sitting here with us, Mary Beth Schreck here. And so this is her and her team's work. We still had open water, or should say very low concentration water in the Chukchi Sea, even into mid-December. Took till right around Christmas for the Chukchi Sea to completely ice over. That is historically impossibly late in the last 10 years. That's become pretty typical. Unlike last year, because of the warm November and early December, sea ice was slower to build out from the Alaska coast. You can see the expansion there in the middle panel as the ice moves south during January, so the extent increasing. And middle of February was just about the maximum sea ice extent in the Bering Sea. Ice got within maybe about 50 miles of St. Paul, but did not ever reach there. Looks similar here 10 days ago or so, with that next advance, again, came within about 50 miles of St. Paul, but didn't get there. Also notice in Bristol Bay that the ice this year was confined pretty far, pretty much to the upper Bristol Bay, never got very far south, and that potentially going to impact that Bering Sea cold pool that they find this summer. Now, I think this is really interesting. This is just a graphic showing the maximum sea ice extent in the National Snow and Ice Center database since 1979. This shows the extent and when it occurred in the season. And the purple, I put the purple circle on there to highlight the fact that this year, the maximum ice extent in this National Snow and Ice Center database was on February 17th, same date as last year. But there's this 2017, 18, 19, 20, 22, and 23 have all occurred in February. Now, it's clear, just looking at this, that these early maximum extents have occurred in other years, but nothing like the frequency of these early occurrences that we've had in the last 7 years or so. I think at this point we need to recognize that the peak extent of sea ice in the Bering Sea may have used to been in mid-March, but it's pretty clear that's not the case anymore. Now, this is the same data, except now instead of when it occurred, this is just a graphic showing what the maximum ice extent was each season since 1979. And I've messed around with this graphic a lot, trying to show how things have changed. And I decided that I was probably trying to outsmart myself by, there's a time and a place for sophisticated statistical analysis, and there's a time and a place for simple. And this is the simple version because I think it tells the best story. So conveniently, we have 45 years of sea ice observations from satellite now. And so that's very nicely, you can break that up into 4 almost exactly equal intervals of 11 years. And then I just chunked the 1979 in with this. So these are basically equal intervals, starting with our first data point. You can see so the 11-year median, I mean, it changes a little bit, but it's not significantly different over those 34 years. And then look what's happened in the last 11 years. This is clearly a different regime. Even last year, which, the ice not only got to St. Paul, it actually for a few days got to St. George in the Pribilofs, was by historic standards pretty wimpy. Our sea ice extent maximum this year, pretty much right in line with this new normal that we're living. One of the most exciting things to me in climate science in recent years, like the last 3, has been the ability to get something like reasonable estimates of sea ice thickness from satellite. Now, we only have data on this since 1911, since 2011. Yeah, we have satellite data from 1911. That'd be kind of interesting, wouldn't it? And so this is what it showed for the week ending March 16th. Relative to this very short 12-year period, where we have ice in the Bering Sea, although it doesn't extend very far south, for the most part, at least this side of St. Matthew Island, the ice is thicker than the typical ice in the last 12 years. And I was chatting about this with Gay before we got going here. And so some of this makes sense, I think, with this repeated changeable weather pattern, but repeated south winds. So the areas that are typically open in the north wind or the ice keeps being pushed away, like on the south side of St. Lawrence Island, that persistent polynya that's there. Well, we've had ice pushed up in there with those south winds. So that makes sense, I think, that the ice south of St. Lawrence Island maybe is thicker than some recent years. Similarly, for the Norton Sound coast, with this repeated south winds, we've had ice move out, then the ice gets pushed back. We finally develop some shore fast ice. But notice there's a little gap there in southeast Norton Sound in this thickness analysis, and that certainly looks like it's real based on satellite pictures and community photographs. Notice also in the western Gulf of Anadir, thinner ice than usual. So, turning to the view from the ground. So here we are, December 16th, this picture from Diomede. There's no ice. Wasn't that many years ago. Some of us can even remember the day when by December 16th, when are they going to get the airstrip in at Diomede? Well, here's from our Facebook page. One of the things I like to do is annotate images and share them out. And so here we are. This is the no ice winter solstice. Normally, we do not have good enough satellite imagery, not enough sun to create good visible pictures from space. But I put this one up. The red line is my estimate of where the ice edge was. And I put this up mostly because of it's winter solstice and there's no ice at Nome. And you can see the ice basically not yet to St. Lawrence Island. We've got these respectable sized areas off the Seward Peninsula coast with little to zero ice, open water even persisting on the northeast Chukotka coast there on the day after winter solstice. So really quite spectacular. December 23rd, you recognize this. So in addition to nearly ice-free seas, the results of the rain lingering here on the roads, but really nice shiny sun on the roads, not what we want to see. Do want to bring this up. This is very different than the ice-free winter solstice. Winter solstice 1905. I'm virtually certain that this picture was not taken because, oh, look at all the sea ice. I think this picture was taken because, oh, look how low the sun is in the sky. I want to point out, notice the quality of the ice. December 21st, this ice is at the end of this pier, that ice is rafted. This ice has significant thickness and it's been moved around by December 21st. Very, very different ice regime than we have anymore. Even in recent years when we have had ice on winter solstice, that more or less looks like the ice that we have right now. All right, here we move into January, a month past solstice. Sun is coming back now, and so we can get some ideas here. The sea ice is expanding here. There's a period of some north winds, so we do have some open water there on the south side of St. Lawrence Island, also near Nome. If you've been watching the Nome radar, sea ice radar when it's running, there was lots of movement of ice. Some shore-fast ice trying to develop along the southern Seward Peninsula coast, but not a lot. Up by Diomede, still have very fractured ice and even a little bit of open water there. Similarly on the eastern Norton Sound coast. All right, Valentine's Day. Kind of a messy picture here. Been a fairly, seemed like it's been a fairly cloudy winter, at least as far as trying to get the good satellite pictures. But here, the ice is looking better. I think overall that we've got ice now south to the west, southwest of St. Matthew Island. Not a lot of water showing up in places that we don't expect it in the northern Bering Sea. There's probably a little bit still on the south side of St. Lawrence Island. Norton Sound looking pretty good, maybe some thin ice there outside of the fast ice in Norton Bay, but all in all, not looking too shabby. If only that would have stayed. A week later, from Clarence Irigu in Gamble. I don't know if Clarence is online or Gay, correct me. That's not ice there in the Bering Sea, that's white caps. Really quite a nice southwest wind here, and churning up the seas, but no ice there. Day later here from Diomede, again, you can see there is some rubble ice right near the beach, but you're not building an airstrip on that water. February 22nd. And from Clarence, a few days later, again, lots of water. You can see Chukotka there in the distance, and lots of water. Looks like you showed that picture. That should be what, like early May? All right, jumping ahead here. So this was the first good picture we had after the March storms, and lots of things happening here. Notice in eastern Norton Sound, we got a whole lot of either low concentration or just plain old open water there from St. Michael on up past Unalakleet, almost not quite to the Shaktoolik there. There's actually a small area of open water right around Diomede here, and areas that I think my expectation is that they ought to have pretty good ice by March 9th. There's that large area there in western Kotzebue Sound. That's some gray thin ice there showing up. Again, a very, very disconcerting picture here. At this point, so Iditarod is underway, and gee, are they going to have problems on the eastern Norton Sound coast here for Iditarod? Here's what the picture looked like from air there, eastern Norton Sound. Yes, it truly was mostly open water, really. Beesbow Island there showing a whole lot. I mean, there's some ice there, but that does not look like Iditarod in eastern Norton Sound. Doesn't look like it should. And then most recently here, my most recent picture here from the 15th of March. So this is kind of interesting. This is a false color image. I like to show these because in the right conditions, they can really bring out a lot of detail that's hard to see. with the just the visible image. And so thin ice there, or even some open water south of St. Lawrence Island. What was the wind direction in the 2 days before this? Yes, northerly. You can see that the eastern Norton Sound ice is looking pretty gray, pretty thin. Even in Norton Bay, right at the edge of the fast ice there. I could it was kind of foggy yet when I flew in this morning, but around and east of Cape Nome, pretty thin ice, looked pretty chewed up flying in. I don't think there was any open water, but a lot of gray ice with no snow on it was evident. And beyond the fast ice there from Sledge Island up towards Wales, you can see a lot of gray ice as well from those north winds. So that's what I have for the review. So Gay, do you want to do the weather briefing now, or should we do the climate first and then come back to weather?
Mute me. Okay, so you have more slides. We know that. And I guess it's up to the audience. Anybody want to hear from the Weather Service? This would be a briefing about our upcoming weather. Yeah. Saturday's weather. Or do you want to wait till the end and let Rick continue? Put something in the chat. Anybody show of hands. We got National Weather Service in the house. That is a rare thing. There they are. Look at that. So let Rick roll.
All right.
All right. Weather Service won't take it personally. Let me get off and unmute Rick. Put a mute.
I just clicked unmute. Good. All right. So everybody online here, okay?
Mute on the bottom of your screen.
Yep, it says good. And a hello, shout out to the National Weather Service as well. They're ready.
All right. All right. Did I get that? Well, I hope I didn't miss a slide there. Starting off with sea ice, since that's sea ice means so much to Western Alaska. One of the fun products that the National Weather Service's Climate Prediction Center produces these days is an experimental seasonal sea ice outlook. Goes out about 8 months into the future. And one of my favorite products out of this is they run, it's got a model system. It's got 20 different models, realizations in it. And so they generate the average date from these 20 different simulations of when the first open water is going to be. So the first date that the sea ice concentration will be less than 15%. And I find this really useful. To me, this is the most useful thing that comes out of this. And I do this, I break this up into half-month increments just to make it easier to read. And then on the graphic, I've labeled that, and then the colors there are on the bottom. So this has got several early things. I think for the Bering Sea, there's not too much here that is unexpected, except for you might be surprised to see first ice-free or first open water there north of Nunivak Island to the east of St. Matthew Island, not until late May. That seems kind of goofy to me, given what we've seen. And I think it is wrong, and I think that is a systematic problem with this model. It does this almost every year now, several years running, and it doesn't happen. So there's something in the model there. Farther north, I think it looks good. Offshore Nome here, northwest Norton Sound, first open water, first half of May. That seems pretty reasonable. That extends up through the Bering Strait. We've got open water up to Point Barrow, the first half of June. Doesn't seem too unreasonable overall. One thing that is really concerning to me about this you'll notice there that it's basically got the ice clearing the Beaufort Sea coast, so east of Point Barrow. First open water in the first half of July there, early July. If that happens, that would be exceptionally early for open water up there. And it could be a model error, although this particular model last year had no dates like this, had ice into early August in that area, Harrison Bay over towards Point Barrow. So that is not a typical error model here, but this is an area in the southern Beaufort Sea. The ice appears to be very thin this year. It's thicker way north, but near the Alaska coast, ice has been persistently thin up there. So this could be onto something, and that could have significant impacts for Alaska climate later this summer and the fall.
I thought the Russian sea lanes opened up really early. You've got them still in late July.
We're gonna have to repeat the question, I think.
Oh,
No, it's good because we're
Okay.
using different microphones. Like you'll just repeat it to your computer.
Okay, so question was,
the Russian sea lanes are always predicted as opening up much earlier than ours over the North Shore of Russia.
so the Russian sea lanes, so north of Chukotka, are typically thought to open up much earlier than ours, but that's not what this graphic shows. Is that, do I got it right there?
Yep.
Yeah. So here we had, so this does have the ice not leaving the north coast of Chukotka here, especially Wrangel Island westward, until sometime in July. That's probably pretty typical. I'd say that's typical. What's unusual is how early it is on our side. Again, we'll see how well this performs. But you are right. But the big thing is Alaska is early in this model forecast, rather than Russia being particularly late. All right. Ocean temperatures are, of course, a big deal. Here is the surface ocean temperature departure from average for the summer months, midsummer months. Again, this is from quite a number of different models, and the reds there, in this case, are actual departures from the model averages. And you can see that Western and Central Bering Sea, a bit warmer than normal, and the hot blob, i.e. where Murbach formed, another very warm summer forecast. I don't know how much I believe the close to normal in the Northern Bering Sea, but that is what this model group is suggesting. Notice that above normal area showing up there in the Chukchi and Beaufort Seas. Again, I think that's reflective of the potential for early meltdown. I should say this model is completely independent of that sea ice model. So we got different systems maybe hinting at early ice loss up north. Now, this will be undoubtedly the most boring part of the program. Monthly temperature and precipitation departures from normal again, we're using our three categories here, and the colors indicate the most favored of the three categories. The white space means that in this system, that neither above or below normal are favored. And there's a whole lot of white space here for the April outlook for both temperature on the left, precipitation on the right, and it only gets worse from here. There's really not much in this climate forecast system to tilt the odds either to favor above or below normal temperatures or above or below normal precipitation anywhere close to Western Alaska. Same in June and same in July. Possibly the most boring set of climate forecasts I've seen in a long time. Now, does this mean it's going to be completely normal for the next 4 months? No. All this means is that the chances, the information going into this doesn't tilt the odds one way or the other. Doesn't mean that near normal is more likely. It means above normal, below normal, flip a coin. Now, that's assuming that these are correct. That's a big assumption.
And what is normal for this? Is this the 1980 to 2020? Are
So
we going from 1900 to,
excellent question.
you might have to repeat it.
So question was, thank you very much. What when we talk about near normal, what are we referring to? And the answer is, as in these monthly and seasonal outlooks, we are using the most recent 30-year decadal averages, so 1991 to 2020. So the modern climatology. Excellent question. Thank you. I wanted to finish up with this question. Has the world gone mad? Well, I think the answer to that is obvious, but at least looking at NOME, this is wearing me out, people. This is wearing me out. On the left-hand side here, this is a list. This is the months that since 2019 that we've set monthly high precipitation records relative since the observations in NOME moved out to Marks Field, now NOME Airport. Six out of 12 months have set new record precipitation. Additionally, in the August 2019, NOME set its highest 24-hour precipitation on record. And that's actually not just since 1946, that's going all the way back to 1906. We've also set monthly 24-hour precipitation records in 4 months, including 2 weeks ago for March. And then, of course, we're going to talk about extremes. We have to talk about ex-Merbach. And, Bering Sea region is one of the stormiest regions in the world, and we really didn't need to add one more way to produce coastal flooding. But ex-typhoon Merbach has done that for us. So that is what I have for you on the weather and climate front. Appreciate your taking your time out of your evening, whether in person or online. So, and thanks, of course, to ACAP, my employer, Northwest Campus, Gay, Strait Science for holding this. To you, I all say Goyana. You can get us here on our Bering Strait and Seward Peninsula Bering Strait Facebook group. If you're not on there, post regularly, not just me, but people around the region, weather and climate stuff. And as Gay mentioned, I do write the Climate Watch column every week in the Nugget. So with that, should we turn it? I think we should turn it over to Ryan, and he's going to tell us how bad it's going to be.
Let's do that.
Yeah,
Yes, let's turn it over to Ryan Metzger. Is that okay? You give us a real National Weather Service update. It's so rare for us nowadays.
Yeah.
It's good. Thank you.
So thanks for letting me give the opportunity to speak today. And so my name is Ryan Metzger, and I am a meteorologist with the National Weather Service office in Fairbanks. And so what I am going to talk about is the storm that we're going to be seeing here this weekend. So I wish I had better news, but it looks like it's going to be a nice storm that's coming in here with basically Saturday, Sunday, looking to have snow. We have a winter storm watch out right now, and that has 8 to 16 inches of snow, 50-mile-an-hour winds, and also it's going to be rather warm. So there's the potential that at times we could get some freezing rain mixing in with things.
How
So
much freezing rain?
I don't think I think it's going to be more on the snow end, but there's the potential that it could just be just a big mess. It looks like it's going to be a nasty weekend. So that's Saturday, Sunday, and then improving Sunday night time frame. But yeah, it looks like it's going to be a doozy. But I'm really actually excited because I'm going to be here in Nome this weekend, so I get to see it in person. Like, I'm not just sitting in my office in Fairbanks, kind of like watching it on the radar or the satellite. So I'm excited to be here in person, and I'm just excited to be in Nome because, like, my office, like, we cover a very large area of northern Alaska. We cover everything north of the Alaska Range, everything from Hooper Bay on up to the Canadian border on the northeastern Arctic coast. So we have a huge area, and it's like it's rare for our forecasters to get out and see the areas, and it's just like it just brings me so much joy that I can actually be here in person to actually like meet people and just get to know the community and like see the places that I've forecasted for so long. So thank you.
All right. All right, I'm gonna mute.
Yeah, thank you. All right, so we do have questions. I know I've got questions. I'm sure other people do, and we want to circle back to the first question that Carol had on the chart. But before we get going, this is the time for those of you online, because you got a round of applause here with the clapping. This is the time for people to put in the chat box some love for Rick Thoman. Never easy to be a public speaker, and even on Strait Science, I know I get nervous too. So you're getting all kinds of emoji things, and but anyway, all good. And and so with that, I think we'll go to the chat box unless someone's smart enough to raise their hand, or just blurt out your question. We do not have any callers online. And if we go back to the question of the March precipitation should be 3.75. Do you know what that one, that?
The graph was
And
departure from normal, I think, not.
all right, I'm going to mute and
I think Rick is muted now too, though.
Okay, had to go back to the Zoom. What a novel idea, right? Okay, so I think Carol's question is about this one. Is that
Now
right?
you gotta share your screen
Oh,
and get back in your presentation.
you know, technology is great when it works, isn't it? Or at least when you have competent drivers.
That's the one.
How's that?
That's the one.
Okay. So on this graphic, so on the precipitation, so the vertical axis there is the percent of normal. So 100 would be exactly normal, 200 would be twice normal. And then the numbers in each box is the actual observed amount of precipitation at the airport. So for March through the 21st, Nome Airport had reported 1.75 inches of precipitation. So that's the melted snow plus the rain that fell. So that is actually more than 300% or more than 3 times the normal precipitation that would have fallen March 1st through 21st.
Just about half an inch should have been falling.
Correct. Does that make sense, Carol? Hopefully it does.
So we have, oh, Penny Hughes wrote percent different than normal. Got it. I think some other people had questions on that. I'm going to mute you for a sec.
all right, thanks everyone while we're figuring out our comms. And so we have Claudia Eel online and then followed by Dean. So go ahead, Claudia, good to see you.
Yeah, hi. Yeah, hi, Rick. There was a graph in there somewhere showing moisture content in the snow. And I'm wondering how that data is measured. Like,
Is
does
Claudia
that actually
talking?
tell you? Can you,
Yes,
yeah, can you hear me?
Might want to let her know. I don't know why.
Can you all hear me?
No, she's.
I unmuted.
She is, Claudia, you're got the mic, so you tell her we cannot hear her.
Claudia, we cannot hear you.
I'm unmuted though.
Is
Gay,
unmuted.
Gay, this is Dean. I can hear her.
Didn't
Yeah.
you mute the computer?
I unmuted myself on my screen. I
Oh.
can hear everybody else.
You didn't mute. No, but she's coming in on this computer. Oh.
Yeah, same as
We
Dean.
just had to, we
Rob,
had to
I
do
can
this
hear
one
her.
so that we could display on the TV. But Gay has the master ring
Well,
to
we're both
control them.
co-hosts.
Yeah.
So it's the same. So Claudia, we cannot hear you.
Well, I don't know. I can hear you.
Okay, all right,
Oh.
I guess she's
Getting
on this
louder.
one, all right. So you need to mute. Go ahead, Claudia.
So tell me if you can hear me or not.
Yes, we can, Claudia.
Oh, okay. Yeah, I wasn't sure. Okay, so my question was, you had a graph somewhere showing moisture content in the snow. And I was wondering how is that measured and what exactly is it showing? Like, is it showing, is that just a way of measuring how much snow fell? Because I don't know, they melted and then they count how much, measure how much water results? Or is it a way of measuring how wet the snow actually is and how much ice it contains? Did you all hear me?
Yes, we can.
Oh, yeah, brilliant. Yeah.
I have to keep toggling on and off mute in order to hear you.
Yeah.
And
Because, you know, the reason I'm asking is because, you know, I researched muskox, and one of the, you know, fascinating aspects of this winter was that because of the extreme iciness of the snow, they changed the way they forage. You know, they can't forage in the spaces they usually go to because it's too icy. So if there's, you know, I'm for future reference, that'd be nice to have a way of measuring the actual iciness of the snow and that particular quality of it, which correlates to the hardness of the snow, no doubt, when it's all frozen.
yeah, thanks. So can you hear me?
Yeah,
So the graphic, so snowpack relative to normal. So this is actually based on 0 measurements. This is a climate analysis model that keeps track of what it thinks, how much precipitation, the liquid amount of snow and rain falls, and then it tries to do the accounting to see if snow melts or runs off. And so this is model based. And what the numbers here are is the percent relative to the 1991 to 2020 average. So
Right.
this is an estimate of the amount of water that's in that snowpack. If you went out and took a core sample of that snow, this is an attempt to show what that would be, how much water that is in that snowpack relative to the 30-year average.
right. So would that reflect though would that basically reflect the fact that it's been raining more while it's snowing, that the snow comes down wetter than it used to?
To the extent that the model, the climate analysis model knows that, yes, that would be reflected in that.
Yeah. Okay.
Now, from this climate analysis model, we can do things that have never been observed. Things like the partition of precipitation between what falls as snow and what falls as rain. That's not
Yeah.
something that's ever been observed in the US. Canadians for many years attempted to do that, but not in the US. But with this climate analysis model, we can actually we can get an idea of that. And
Oh,
again, it's a model, and so it's probably not good. You know, you wouldn't want to use this for how much ice was there or how much rain was there on the top of Anvil Mountain. It's not
right,
that
yeah.
resolution, but at the sub-regional scale, it's probably get us in the ballpark. It did, from what we can tell, it did very well in December 2021 with the extreme rain event from the Seward Peninsula on into the interior. It did very well.
Yeah.
But we have reasonable confidence that in this model for those kinds of things.
Right. Okay, yeah, thanks. Thanks.
Thank you.
Stockwell.
Dean, you're up.
Yeah, Rick, nice talk. Really enjoyed it. Slide before this, you showed exceptional precipitation, 1.75 inches of rain for Nome. There is no snow data to go with this, and this is kind of directed towards the Weather Service. If I have an unusually heavy snow event, won't you see that precipitation number increase also? And my question is it not a simple or relatively simple way of gathering data to collect snow in the Nome area? And why isn't the Weather Service doing that?
I'll take the first part of that. And
Thank
then
you.
turn it over to the Weather Service. So the numbers on this graphic are showing the precipitation. So the amount of melted snow, so the water content of the snow that falls plus any rain. So that's what we mean by precipitation in this graphic. So, and this is all from the automated station at the Nome airport. As far as,
But if I have an elevated snow event, those precipitation numbers are going to increase.
yes, absolutely.
Okay,
So if Nome gets a foot of snow this weekend and that melts down to, let's say, 1 inch of water, then this would go from 1.75 to 2.75.
gotcha.
Okay. And so for the snow question in Nome, I turn it over to Ryan.
Yes.
Don't mean to put you on the spot, Ryan, just a question, you know?
So as far as snow measurements in Nome, it's very unfortunate, like due to staffing at the weather station here in Nome. Up until a few years ago, we had 24-hour round-the-day coverage here, and the Weather Service, like higher ups, decided to cut that back. And so with that, we don't measure snow in Nome anymore. And it's very unfortunate. It's very, it becomes challenging for us as forecasters in Fairbanks because we don't know when we're doing our forecasts, you know, how they're verifying in terms of snow amounts. And it's not just Nome, it's other communities around rural Alaska. So, you know, Ukiagvik, Kotzebue, Bethel, you know, places where we had a record of snow for a very long time and we stopped doing that. And it's just very unfortunate. You know, there's not much more I can say about it, but it's very unfortunate.
Can you give a
Yeah.
shout?
A good example, you know, last December snowfall was somewhat normal. The year before, we had a really heavy snowfall here in Fairbanks. Those types of numbers would be valuable to any of your models. So I'd be a proponent of increasing the measurements there in Nome, or at least somewhere on the North Coast, just to get that data to enhance your models. But I understand the predicament you're in, and thank you for your time.
Yeah, and I will say that around Alaska, we have what are called cooperative weather stations. And when the Weather Service office here reduced in staffing, we set up a cooperative weather station at KNOM. And so they do measurements for us. And it's a different type of weather station than like the Weather Service owned and operated stations where you have a Weather Service employee who does it on a regular interval at regularly scheduled times. The cooperative weather stations are very valuable, and we have them all over Alaska. But it's very different than like the Weather Service owned and operated stations.
Yeah, I look at the Alaska, I forget its actual name, the Alaska Climate Research Center data, and for at least for Fairbanks. And I also look at that for Nome, and I can get maximum and minimum temperatures, and I can get precipitation. But that snowfall effect is missing. And yeah, I sorely miss that. But thank you.
Thanks.
We have an in-house question.
I have 3 questions that have bothered me for quite a while, and I'm looking for a weather person that can tell me. My daughter lives in Colorado Springs. How come, she's a mile above us. How come she has consistently higher pressure, air pressure, than we do in Nome? She should be much lower air pressure if she's a mile higher, shouldn't she?
So the question is, why does it seem that in Colorado Springs, the air pressure is routinely higher than here in Nome? And the answer to that is it isn't. In fact, you're exactly right. A mile up, your pressure is much lower. However, what gets reported as pressure is typically reduced to sea level so that it's a apples to apples comparison. Now, when you're a mile up, that conversion makes a lot of assumptions about what the atmosphere would look like as you went down to sea level. So in some ways, it's a artificial measure, but unfortunately, meteorology has been doing it for 150 years, so probably not going to change.
Then the second one is when I was a chemistry major, 60 years ago, 760 millimeters of mercury was the standard 1 atmosphere. We've never hit that here in Nome, here at sea level where it should be recorded. How do they judge what the standard is for a chemistry experiment?
Not being a chemist, I will have to.
Physics does the same thing.
Yeah,
The
I will have to.
standard 1 atmosphere is always 760 millimeters, and we're about 720, 730, and that's way under.
It is a big difference. Part of the answer there is that basically here in Nome, Alaska, at high latitudes, we got less atmosphere above us than they do down in the tropics, and some of it is, of course, here in Nome, which is a stormy area. It is, yeah. And now squeeze that down to sea level, get even warmer.
And the third one is,
These are amazing.
I keep hearing about the percentage of precipitation. There's a 50% chance of rain. Can you explain that and say something I can understand?
You bet.
I've got 2 experts in weather who use this regularly. Please tell me what you're saying.
Okay, so the question is, what does X percent chance of precipitation mean? So if I say that tonight there's a 50% chance of precipitation, what does that mean? It does not mean what you think it does. It does not mean it's going to precipitate 50% of the time. What it means is that if we had a whole bunch of tonights with the same weather pattern, 50%, half of the time, there would be 1/100th of an inch of precipitation or more in the tonight period. Now, you don't know, could be a Murbach, could be 2 inches of rain tonight, as long as that percentage only tells you 1/100th of an inch of precipitation or more. 1/100th of an inch of precipitation is about enough to completely wet the ground. That's all it tells you. And that's assuming that it's right. So I say there's a 50% chance of precipitation tonight and it doesn't precipitate. Is that forecast right or wrong?
So it's like making odds on the weather.
Right.
You should be doing baseball instead of weather.
Many people have said that. So you're right. The answer is one forecast and one outcome. You don't know whether that's good or bad. You need a whole bunch of them. And if you have 100 days, when I've said there's a 50% chance of precipitation, then hopefully about 50 times in 100, that will have happened. Then you would say, great forecaster, even though might be wrong 10 times in a row. That might be right 10 times in a row.
They do it every hour now.
There you go. Yeah, oh yeah, yeah.
They've got percent by the hour.
Yeah.
So you have Rob Keeler with his hand up.
Hi, Rick. Can you hear me?
I can hear you, Rob. Can you hear me?
Yep, I can. I follow you on Twitter, and maybe this is more political, but I can still follow Brian Brettschneider. I see his posts, but have you left Twitter? Because I used to really enjoy your your updates via Twitter. So, and again, thank you so much for a great presentation as always.
Thanks, Rob. And I am no longer on Twitter. I am on my Mastodon, Alaska Weather.
All right, I'll look for you there.
Not on TikTok either.
And I'm not on TikTok.
That was my next question. Yeah, I don't do Facebook, I don't do Instagram, and I don't, yeah, but anyways, I'll look for you. Thanks, Rick.
Does anyone in here have questions? I know I have a question. Good, you guys are good? Did you want to say anything about that snowpack or relevancy?
It just kind of followed Claudia's question, just because it's, from working with reindeer, understanding when there's an icing event and how that's going to impact grazing, especially in the winter when they have to dig down for everything. Last March, we were out in Sabunga, and among the kind of like craggy areas, you could see just like kind of blood streaks around the rocks and the ice, and they were trying to hook down to get to the lichen, trying to have some kind of a, I don't know how you would like utilize that to say, oh, you're gonna have an icing event, so move your herds to, you know, an area that's not gonna get hit with that. I don't.
Yeah, that is a tough one.
Can you somewhat summarize that for the people?
Oh.
Sorry. No, it's all good.
So the question was basically a preface with the impact of these winter rain events and the resulting icing in your example on a reindeer on St. Lawrence Island. And so the question is, what I could think, could that be forecast?
Yeah, to a certain extent.
So Weather Service does attempt to forecast that. As Ryan said, it might warm up enough this weekend to be some rain. That off, except in the really extreme events, that tends to be highly variable over short distances. So it's really difficult to move your herd from here 5 miles over here. That's beyond the state of the science. It's an interesting question from my climate perspective. Could I use icing per se is not going to come out of this, but could I use somehow that for instance, the amount of precipitation that falls as rain, could I work that with the amount of snow, the precipitation that falls as snow? Could I work that into some kind of icing index? That would be very tricky because if the snow melts out, if it snows, then rains, and it's all gone, then that's a different scenario than if it rained an inch this weekend. It's not going to, but if it did, that would be a very different icing scenario than say in November. So might be interesting ways to work that from the forecast point of view. In general, it's going to be a yes or no kind of thing with low spatial resolution.
Oh, Megan, I'm sorry. Go ahead. Rick, you mentioned that we're excited that in recent years technically sea ices. Can you explain what kind of advances allow that?
You bet. So it's been possible since the early 2000s to get an estimate of the thickness of thick sea ice from satellite. And that's worked reasonably well up over the high Arctic. And so that's good. The sticking point, especially relevant for our part of the world, is for ice less than about 3 feet thick. What's called radar altimetry does not work very well. Works good for that thick ice, does not work so well for the thin ice. And in recent years, what this product actually is showing, it's actually a merge from two different data sets. One that does that thick ice well, and another that doesn't do thick ice well, but does a better job on thinner sea ice. And so this is a combined product from the Alfred Wegener Institute in Germany that combines these two different satellite-based products into one. And that has been a real advance. Again, this is a very short-term I would normally never, ever use 12 years as a climate record, but it's what we've got. And so I think we've got enough now. I think it's worth looking at. The other thing I should say is that they revise this every year. And so this, if I show you this exact thing next year, will look a little different because they will have revised it. It's not like we're going to see thin sea ice show up in Norton Sound, but it would look a little different because it's a, that's one of the things about what the Weather Service does. What I do is, we're at the bleeding edge. Operational work, we're using what we can. This is not, ivory tower, we're gonna sit on this for 5 years while we test every bug. We run with what we got because we're trying to provide information that people need now. And we know it's not perfect, but it's the best we got. And the best is hopefully going to be getting better with time. And I think this is a nice example of that.
I'm just gonna come up and ask my question. No one else is. I'm just gonna come up.
I can't push the buttons fast enough. So my question is, well, what first was, Lou brought up the sea ice on the Russian side. And for the National Weather Service, if you live in the Bering Strait region, we know that's incredibly important. And I want to mention that while we have National Weather Service, because it is really important for us to know, because now, especially the industrial maritime ship traffic that is coming through our area has a lot of potential impacts and challenges for us. And it is really interesting. And there's probably a lot of other people in other places of the country that are watching that, but it would be really great for us to know the quality of the ice along the Northern Sea Route. And when Rick always puts in by fall time, I think you show like how it's been on the Northern Sea Route, like when it was open and when did ships start. That kind of information is really probably not intuitive if you're living in Fairbanks, but it's really important for us. It's very important for us. So I just wanted to mention that while you're in the house. The second is, I know this is Bering Strait focused, but even on this map that we're all looking at, this sea ice thickness, when Rick is saying that Eastern Beaufort Sea is of concern, and I've been looking, as we looked in all those pictures, it's kind of given it up. And I know that Koktovik has had an unusual situation with open water in the beginning of March, and it may not be intuitive to think about the Eastern Beaufort Sea, but I'm going to ask about that because that is where our bowhead are headed for the summer. And what is driving that persistent in all your pictures? I was kind of cheating and looking up to the northeast. What is driving up in the northeastern Beaufort Sea? I mean, the Eastern Beaufort Sea. Why is the ice so weak? Do we know? Is it the weather? Winds or something?
Mary Beth.
Oh, all right. We're getting another one. Stand by.
So Mary Beth Schreck, and she is the senior sea ice analyst for the Alaska Region Weather Service. So the expert is in the house.
Down.
Let's see.
I'm not this tall. So we did see earlier this season that the sea ice up along that the North Slope coast, just beyond the shore fast ice, when we had some southerly winds there, it pushed the thicker ice kind of up north. It kind of compacted it more, and then that refroze. So that is thinner now than it would be if that ice hadn't moved away and refrozen. So now that's lingering. It seems like every year as we melt westward from the Mackenzie River Delta, that it, if we get a good storm that has like easterly winds, then it'll open that up a little quicker. We could get warmer if things break up quicker along the Mackenzie River, and more warmer water comes out. So that does vary, it seems like. But I think the big thing for right along that coast is just how it had moved away and then refrozen, and then that kind of got set in there.
Thank
Does that
you.
help?
Yeah.
Okay.
It's so wonderful. We have this
Immediate on demand. It's real wonderful. And I think everyone else is enjoying, having the Weather Service right here at our, and of course Rick, but these special guests pop in. And then also, my other question, kind of animal related, not surprising, would be the change in, when I look at your sea ice extent, yay, Weather Service from someone, so. The February, where it's now February is our greatest extent. So I, again, am thinking of our subsistence issues and what they have to do in all our marine mammals and seabirds and things like that, that have their own timing for their own mating, breeding, so forth and so on. So I'm just thinking, so do you think as we move forward that this situation where we have maximum extent, so the farthest the ice is going to go in the south is February, because that certainly makes it, the weak ice makes it more wind dependent, and then if it's not even getting down very far, the ice is, it's a shorter trip back north, and you have less time maybe to get things done that you need to get done if you're an ice associated creature, like even ice algae. But you think it's going to be persistent or a trend?
I think that is a difficult question. The trend towards lower maximum, I think, we know that. Ocean water temperatures in the Bering Sea are rising. It's harder to push the ice farther south. Ice is forming later in the fall. There's just less time. However, when the ice extent is relatively low and is easily moved around by the wind, I might expect that, oh, the ice is fairly far north in February, but now we get a cold March and lots of north winds. And so if the ice extent is relatively low, it doesn't take that much to push it farther south. So I would not have guessed that in this era of reduced maximum sea ice extent in the Bering Sea, that it would occur necessarily significantly earlier. I think what this is reflecting, though, is the very warm waters south of the ice edge. And I think at this point, that's winning. Will that continue to be the case? I don't know. When we start regularly having maximum sea ice extents like we did in 2018 and 19, maximum extent could occur later, but it's still really low. So my idea is that the timing of the maximum extent is to be determined, but this clustering here in February in most recent years is somewhat disconcerting to me.
I have one last question, but we did just have someone in the chat box write. They came in a little late. Did you make a prediction for spring and summer?
It's coming.
Yes. For the 4.5 billionth year, the sun in the end will win. And the snow will melt, the ice will go away in the Bering Strait region.
100%.
The capsule summary of the spring and early summer outlooks is the climate models have no confidence to tilt the odds towards above or below normal, really for anywhere in Western Alaska. Doesn't mean it's going to be near normal. It's that climate models, and I should say the expert opinion from the Climate Prediction Center as well, basically is not tilting the odds either way. So we'll just have to see.
Okay, and last, because I just love this, having this opportunity. So for your climate outlook, April through August, you said it was boring. Like it was going to be normal.
No.
Right? Get back up here, because that was what I was like, what do you mean by boring? Like, is that, why is it going to be normal? But it doesn't sound like I got it right. So take it away.
That's it
So,
for me.
so the outlooks are boring only in the sense that they don't show any tilt to favor significantly above or significantly below normal temperatures, or significantly above or significantly below normal precipitation. That definitely does not mean that the forecast is near normal. It means we don't know. There's not enough signal. There's not enough evidence in the system, in the Earth system, to tilt the odds to favor one or the other in what I showed particular models, but also in the broader expert opinion from the Climate Prediction Center has those very bland forecast. Does not mean, I mean, what it means is Nome has as much chance of having the warmest summer ever as it does having the coldest summer ever. That would, neither of those would be boring outcomes. But both are consistent with the climate outlooks that don't show any tilt. If they showed, say, a tilt towards warm for the Seward Peninsula for the summer, that would mean that the warmest summer ever would be slightly more favored than the coldest summer ever. And I should say ever here is in relation to our 1991 to 2020 normals period, not 1908.
I'm handicapper.
Yeah.
Yeah.
That is a lot of this job, and I've been trying to explain this for 35 years, and we'll just keep on going.
One sec. So this is Gay. So we have, I'm gonna do stop share so we can, I can't even see anything here, but. All right. So, right now we have this storm rolling in and the National Weather Service is writing down, they're gonna put it in the chat box if anyone's in Nome and all of us here. If there's photos, and I know Rick is keen on photos of the snow. You can contact the National Weather Service in Fairbanks, or do you want to give us what you might look for, how we might be able, if this is a big storm rolling in with that much snow and wind and maybe rain, how we can all help National Weather Service and Rick Thoman with our cell phones and things like that. Do you guys want to duel that on what might be helpful while we're all on?
Yeah.
Okay, Ryan Metzger.
Hi, so it's Ryan Metzger again.
Flip the camera.
And I needed something. Yeah, sorry. So we have an email address. It's fairbanks.weather@noaa.gov. And we also are on Facebook and Twitter. And our handle for both is NWS Fairbanks. We cover everything in northern Alaska, including Nome, including the Seward Peninsula. So we would love any pictures you have of snow, and like if you have a ruler at home, stick it in the snow and show us what you have. Reports of what you're seeing, if you're seeing freezing rain. All of that's very helpful for us to help us get, assess the situation and get things, so we can better our forecasts. But any information you can send, fairbanks.weather@noaa.gov, and on Facebook and Twitter @NWS Fairbanks would be great. We really would appreciate it.
How do you tell wind-blown snow from drifted snow?
That is,
He's excited to answer.
yes, that is like the age-old question.
You might repeat it, they probably couldn't.
Yeah, so the question about wind-blown snow versus falling snow, how you tell the difference, and it's really challenging to do so. You kind of have to, in situations where the snow is windblown, you kind of have to take multiple measurements in different locations, and kind of like, you can see like some spots where it might be bare ground, or like it has blown all the snow away, and so that's probably not a good place to take your measurement, just as the same as like the big high drift. Sometimes
Keep going.
sometimes the weather, like weather observers, who they'll measure the liquid amount in the snow, and they kind of like, they'll use a ratio of 10:1 from the melted liquid to the snow. But that's the snow ratio varies from storm to storm and situation to situation. That's not always the best approximation, but in a pinch that can work. But it's a really challenging thing with snow that's blown around.
And this is Rick, and I would put two exclamations on what Ryan just said. Measuring snow in tundra environments is extremely difficult. It is extremely difficult. It's not even clear to me that snowfall is a well-defined parameter. But it's not like, oh, well, you know, it's not easy. It is very difficult to do right. It is, and it's so difficult. If somebody says, here's $100,000, go measure the snowfall and snow depth. You would be hard pressed to do that with 100,000. You'd be hard pressed to do it with any amount of money because it's so difficult to do, but it's so important. Look at the difference outside Nome right now compared to a low snowfall winter. And what's it going to look like Monday morning, right? It's going to be even more. So it's really, really hard, but it's really, really important to do. And I think one of the things that I'm hoping to get, and you can help if you want, I would like to just document in nice, clear pictures just how difficult that is to do. Measuring snow, even measuring precipitation, it's not as simple as dip your ruler in the snow and that's the snowfall. That works great about 99% of the time in Fairbanks. Here's the story I like to tell. I worked at the Weather Service in Nome for 2.5 years. I used a ruler to measure snowfall twice. Because almost always when it snows, it's wind driven. That was at the airport, at the old airport. There was no unplowed, undisturbed ground anywhere close by. Twice in 2.5 years, I used a ruler to measure snow. So it is difficult, but it is worth your best guess. Not just snowfall, but things like the March 2021 storm, when the ASOS was broken at the airport. That it wasn't just not communicating, it was not working. We've lost that, what I think was a record snowfall event, precipitation event, to the automated observation at the airport. But thankfully, we had people on our Facebook site posting pictures of, I parked my car here before the storm and now my car is buried. That kind of documentation is so useful. So while we live, we will know that the March 21 storm was massive because we have picture evidence of that. Just like that guy in 1905 that took that picture of, look how low the sun is. He has inadvertently documented for us how dramatically different sea ice was in that winter. So thanks for your help.
All right. And with that, anybody else? No one online, which I can't really see anyway, because I'm not on my computer, but thank you all so much for coming. If there's nothing else, anyone, no questions? I can't see the chat on this.
I don't see anybody on chat. Okay.
Wonderful. Thank you very much, Rob. And thank you all for your patience with our comms while we figure out the hybrid system and avoid our new microphone system. But anyway, next week, next Thursday, we'll have our next Strait Science. It's going to be about harmful algal blooms. And if we saw also the shocking sea surface temperature map that Rick showed with the departure from normal for the 3-month average, December, January, and February, where you have that white area and a little bit of blue for where the sea ice is, and then 1 degree to 2.5 degrees Fahrenheit above normal for a 3-month average in the dead of winter. We're going to be having a harmful algal bloom talk next week, next Thursday, regarding seabirds. There's been some research that the U.S. Geological Survey, who is the federal arm that does research on seabirds, and they have been using captive birds and trying to get some of the first impacts and dosages on what it takes to make some of our seabirds unhealthy in a healthy, controlled way. And they will be giving us their results and what we might be able to look for this summer. and hopefully report if we see such things. Hopefully we won't. But anyway, stay tuned for next Thursday night. We have Matthew Smith and Sarah Shane from the U.S. Geological Survey giving us information regarding harmful algal bloom algae and the our seabirds up here using captives in Alaska. With that, I'd say that's it. Thank you so much, everyone, for joining, everyone here coming in, and we'll see you next week. Good night.
Thanks, everyone.